Hi, I'm Riley. I have the Ullmann and the Buchwald-Hartwig amination slash etherification for both of them. They're both very similar in terms of reactants, so they both need this aryl halide R substituted X, the halide group, and an alcohol slash amine group with an R group, depending on whether it's the amination versus the etherification. So the Ullmann, in terms of reagents, differs from the Buchwald-Hartwig because it needs a copper catalyst, while the Buchwald-Hartwig uses a palladium catalyst, along with a bidentate ligand, with some examples here. So you can use DPBF or DPBA, etc. They both are done in base, but the Ullmann is better at higher temperatures, while the Buchwald-Hartwig is better at lower temperatures. First, I'm going to show the Ullmann amination, which, as you can see here, has the aryl halide group as one of its reactants and this nitrogen substituted group along with the copper catalyst instead of the palladium. And for the Buchwald-Hartwig, it has the same aryl substituted halide group and the nitrogen as the previous one, but the only thing that differs is that it has the palladium catalyst and a bidentate ligand on it. So it's basically the same thing for the etherification, except this group here, this is an alcohol R substituted group rather than the nitrogen. The copper catalyst and palladium catalysts are the same for the other ones. So I'm going to show the mechanism for the Buchwald-Hartwig amination. You can see it starts with the aryl halide group and it goes through an oxidative addition using the palladium 0, which substitutes the palladium directly onto the ring. And then it goes through nucleophilic substitution using the nitrogen group, and hydrogen from the nitrogen gets replaced with the iodide, which sends out Hi, and the nitrogen gets directly substituted onto the palladium, which is palladium 2. And the last step is a reductive elimination, which forces the palladium out back again as palladium 0 so that the reaction can go again. And we finally get our product, which is the nitrogen directly substituted onto the ring where the iodide used to be. So this is a literature example problem that I have, which is the same type of problem. It's the Buchwald-Hartwig amination with the aryl halide and the nitrogen group. So you can do that, pause that, and do the mechanism for it and get this problem.